Remember, when you are working with, and you're just factoring stuff like this, what you're looking at here is, watch the degrees. In this case, when you have 3 terms, and the degrees are getting cut in half each time, treat it like you would a quadratic. What times what's 2 you add together to get 3?
I wrote 3x to the third, and I was so confused.
Yeah, then you'd have issues. So, yeah, this one just winds up being x squared plus 2 and x squared plus 1. And you're done. You can't go any further with that. Guys, come on. Way too much to worry about today, then have to talk to everybody. Not like I don't want to talk to you, but you know. 54 I've had a lot of questions on. Same reason. What's loads? You're doing the same exact thing. Treat it like you would a trinomial. What times what's negative 36? You add together to get negative 5. You should know that. 4 and 9. So it's 4x to the fourth minus 9x squared plus 4x squared minus 9. And now you're going to do your GCFs. You get x squared, 4x squared minus 9, plus 1, 4x squared minus 9. X squared plus 1 and 4x squared minus 9. Can I go any further? Yes. Which one?
4x squared minus 2x.
So I go further on that one. I get 2x minus 3 and 2x plus 3.
Stop! Don't do my homework. You just ripped my homework. Mr. Murphy, you just ripped my homework. And I did it. That's surprising.
As long as it's fun for you, I hope you feel better.
What am I going to do? I did not. I have to go tape it.
Same thing.
Can we do 84?
Wait, what number was it?
84.
What's up? I'm going 84 first. I'll go back. Obviously, I set aside equal to 0. So I'm going to set aside equal to 0 and take GCF right off the bat. Take out the 3x to the fourth, and I get x cubed minus 27. I got to factor that further to find my zeros. First one's easy. 0. I set 3x to the fourth equal to 0, and I get 0. It's got multiplicity there at 0, 4 times, but we're not worried about that. Here's a difference of cubes. When I have a difference of cubes, I have to do the x minus 3, x squared plus 3x, plus 9. I cannot factor that any further, so then I'm done. Find need to get a drink, go ahead. If I have to find if it asked me to find my real zeros, which I think it did, it said real or rational, I believe. Real. So you got to find your real zeros. That means I go back to here and I have one at 0, 3, because if I factor that, I can't. I'd have to use quadratic. So if it says find all, then you have to give me the imaginary root here. Negative 3 plus or minus square root. 3 squared minus 4ac all over 2a, and then you just figure it out from there. You'll wind up with a pair of imaginary solutions. Okay? Well, I forget, you said 29 or 39 or what? 39?
Yeah.
Question on that?
60, please.
I will get to that. I just thought you had a question on that. What's your first rule of factoring?
GCF.
What's the GCF? 4. You got the 4. 8x cubed minus 1. What's the cube root of 8x cubed? 2x. So you get 4, 2x minus 1, 4x squared, plus 2x plus 1. Yes. pass.
That's what I was wrong. What you were talking about was right. I did it wrong. It's all right.
You having a bad day or no?
I just don't know what I
You did a good idea.
Where did these come from?
Well, I'm not going to put stuff that you don't know how to do into it.
I don't know.
Page 3.
That's weird.
What was it, 60 you said?
I wrote the wrong thing.
Was it 60? 60?
Yeah, yeah.
First rule of factoring. What's GCF in 60?
3x.
Factor out of 3x, you're left with 2x squared plus 7x plus 5. 2 times 5 is what?
10.
What times what's 10? You add the other to get 7.
2 and 5.
2 and 5.
2 and 5.
Stop touching it.
So this one has zeros at 0, -5/2, and -1. If I asked you to graph this using your tails, what direction would this be going? Down, up. Very good. It's going to go down, up. 0, -1, -5/2.
It didn't ask us to do that, did it?
Correct. But if it did,
Yeah, I was just making sure.
down, up. That's what it looked like. If it asks you to do that, you would do that.
Did it?
No, it did not. But remember, I've been asking you to do a lot of things that the book doesn't ask you to do. What do you think? If it says to,
Stop. Oh,
Not
my
good.
God.
I'm confused about this point is the multiplicity. How do you know what happened?
if it's a repeated 0. I think there is one of them in there. There was one where you had an x squared on the outside, and then you had 2 other terms. Fourth degree. Was it the 4th degree polynomial? 66. Give me 1 second, all right? I'll get back to you.
So it's only for that.
Oh, no, it's 66, but that's going to give you a trinomial. Yeah, but that's going to be, that's a specifically weird case. What happens, I know what you're talking about. What happens sometimes, let's say you get a factor, you have x squared, and then you have x minus 1 and x plus 5. Let's say you found all of that, and you got to figure it out. Well, that means you had a 4th degree polynomial, all right? Which means you get you up to 4 possible zeros. -5, +1, and 0 repeated, because it's just an x squared on the outside. All right. You just figured out that's where it came from?
Yes.
Okay.
So it's only
Because remember, what this means on the outside, x squared is just x times x. So I'd have 2 of them to set equal to 0. I have multiplicity at 0. That's all that means. If you graph that, that means it changed direction at that spot. 4th degree polynomial, in this case, it would be tails up, because the first term was positive. If you FOILed it out, that's what it would look like. -5, 1. So tails up. That's what it would do. That's all it means. What if it's 2x squared? Then you set 2x squared equal to 0. You still get 0 twice. No. No, not at all.
Wait, are you being sarcastic?
A little.
We have.
Yes, we have.
We didn't actually do.
Yes, we did. We did. If you recall, there is a whole sheet that we did.
That was the day
No? Right. Oh, this one's in it. But there was one that I made with the 12 problems that we did. Okay. Big, what do you got?
If it's an X cube on the outside and the interior.
It's a weird case. It doesn't mean it's touching it 3 times. It doesn't loop back to go to it. It's a weird case you'll worry about in pre-calc, and I said that yesterday.
I didn't realize that we have.
Okay. You didn't have to graph anything like that. Okay, not with the multiplicity. With the multiplicity of zeros. I don't know. Fight for it. Who wants to go?
With the multiplicity.
Hunger Games.
Only 2 and then 3 is not multiplicity.
It's still a multiplicity, but I'm not going to make you graph the multiplicity of 3. Okay. What do you got? Just one. What do you got?
Oh, okay, so when you do the sum of the cubes and the difference of the cubes,
Yeah.
how do you know which one it is?
Is there a plus sign or a minus sign?
But like, so if there's the minus for
Then it's
the
difference.
cubes, but then at the top, then the equation is a minus.
Right. Yep. Remember, if it starts with a minus, it's minus plus plus. It starts with a plus, it's plus minus plus. Okay. What do you got?
Just generally speaking, what we have to know.
You just jumped over. Were you a second? I don't care. Fight for it. I'm thinking of a number 1 through 5.
Okay, I'm just gonna go.
It's 7.
Generally speaking, what we have to know for the quiz.
Everything from 6-1 to 6-4. Next question. What do you want me to say? Do you want me to just give you the quiz so you can study it and come back tomorrow?
Yes,
No. It's your, guys, ladies and gentlemen, guys, you do understand that this is an honors course, and I hold you to a higher level. Okay? You've got everything. There's no silver bullet. There's no, it's going to happen every single time the same way. It's a matter of going through the problems and looking at and solving it. The way that we've discussed it, the way that we've written it out. We've done everything from 6-1 through 6-4, which means I can ask you anything from 6-1 through 6-4. Does that make sense? Okay, next question. Yeah. No. No. We're not graphing imaginary. Yes, sir.
No, I'm just asking how it works. Like, the outside number was like 3x or something, and then 3 and x. Would it just be 1 because 3 is not equal to
Correct.
0?
Yeah. Because what happens, we've seen this, where you have, if it's 3x, then you have other junk here and here. All that means is when you're setting it equal to 0, you've got 3 separate terms to set equal to 0, solve for x. So 3x equals 0. What does x have to be? 0. That's all it is. Yes, ma'am.
Okay, so if it's 3x and then parentheses and then minus the next parentheses, would that be 3x minus 1?
No.
Like it's implied that it's.
No. No, there's no subtractions in here. It's just multiplication. Those are your terms after you factor something out.
No, but like 3, 7.
Let me look. Let me put it up. You might be confusing it with a different style. 72, you got to get the side equal to 0. So right off the bat, subtraction 2, you got x cubed, 2x squared minus x minus 2 is 0. Guys, stop. Please. Do you guys. All right. Okay. 4 terms. All 4 of them are descending order. It's forcing you to group. When you group it, you're just pulling GCFs. Here I gotta take out the -1.
Yeah, and then you have to do the x squared minus 1.
Yeah, I thought you were talking about something out on the outside here. So you have plus minus 1 and -2.
So you don't need to.
Yeah, because that's just a difference of squares, so it's x plus 1, x minus 1. If it was x squared minus 9, it'd be x plus 3, x minus 3. That's why I was writing this plus minus 3. 3 zeros. You can factor just like you would a quadratic at that point. What else you got? First rule of factoring is what? Okay. GCF here, take out the 2x squared. I get 8x to the 4th minus 1.
Good 16.
Math is hard. This first term of perfect square.
Yes.
This last term of perfect square.
Yes.
That's subtraction
Yes.
sign.
Yes.
Okay. 2x squared, 4x squared minus 1, 4x squared plus 1. Can I go further on any of those?
Yes.
Which one?
4x squared minus 1 plus
2x squared, excuse me, 2x minus 1, 2x plus 1, and 4x squared plus 1. And since it wasn't equal to 0, all you do is just factor it. Okay. Eventually, we will set that problem like that equal to 0 and find all zeros, which will happen in 5, 6, 6, somewhere in that neighborhood. Okay. Okay.
So when there's a multiplicity, do you want us to just write the number once, or do we have to write it twice?
You can write it. Just if I ask you to graph it, just that's the multiplicity of the multiplicity of 2, it just means you change direction. That's all.
So is that the last one you did that thing, you just have to solve it now.
No, you can't go any further. You're done. Because you can't break the thing down any further, because 4x squared plus 1 is a factor of 1.
So you can't make it plus or minus.
You could, but does it say equal 0?
In the question.
Right. It doesn't. If there's no equals something, that means you have to solve for your zeros.
Oh, like if it doesn't, if the first pattern is 8 equals
Right. Sir?
So if it has like x to the 4th on the outside, like that's what you factored out, does it hit the 0 4 times then?
You'll learn it pre-calc. Don't worry about it. I'm only worrying about it with multiplicities of 2. For you guys, for as far as the graph is concerned. Everything else you can learn in pre-calc. I'm not going to bother with it here.
All right.
It gets to be messy, and it's
Yeah,
not. We
yeah. I was
don't.
just making sure that we
Yeah.
didn't worry about that.
Like I. Yeah.
He said
Said it like a lot.
Oh.
I mean, he hears me. He's got earphones over his ears, and he still hears me.
I'm like not here most of the time. I'm not like
I've gotten good at
at school most of the time.
It makes sense when, yeah. Hate to agree with you, but I agree with you. What else you got? Yeah. Yes, sir.
I was just kind of wondering, it's more like a concept kind of question. For number 84, you got zeros as like imaginary numbers, but when I graph it, I can still see the zeros there. So how is that happening? Are they imaginary numbers when we not show the graph? I mean, I understand how to like factor it in.
Gotcha. When you go through this one, you take out your 3x to the 4th. You get x cubed minus 27. Okay. It went through 0. It went through 3. And that's all you're left with. Your zeros, the real zeros are at 0 and 3. So you're right. If you did graph that, yeah, they're okay. Once it loads. You won't get a graph calculator tomorrow too, so you know. What was it? X to the, what was the original problem?
I think it was 3x.
3x to the 7 minus 81 x to the 4.
Minus
81
8.
x to the 4.
Thank you. That's exactly what it looks like.
How does
It has an even multiplicity, so it changes direction. And it goes through the x-axis of 3. You have real zeros at 0 and 3. Play the game of your tail stance. Your tail stance, your first term was positive. Your exponent was odd. Down, up. Follows the same rule. You just don't see imaginary roots. So conceptually, when you talk about that, when you put it in calculator, you're right, you're not going to see them. And that's correct. So you're not overthinking it, you're not thinking it's weird, you're doing the right thing. Right? I mean, does that help a little bit?
Yeah, but like, why even solve for them?
Because they're there. Correct. You also have the idea that, remember when we worked on regular old boring quadratics? When you graphed a quadratic, it could go through the x-axis twice, it could touch the x-axis once, or it could be above or below it, right? When it was above it or below it and not touching the axis, that just meant it had imaginary roots. Same deal. There could be another twisted change of direction somewhere along the lines, that's just not going through the axis. That's all. You'll analyze graphs of polynomials a lot more in pre-calc. What you're going right now, you're going to be fine. Okay? Yeah. If I asked you to solve for zeros, because you can't factor that.
So if you can't factor it, solve by
What do you got?
Wait, how would you find what I would?
You would just use quadratic, just like it was right here. Like in this case here, if you had to find all zeros, which you will do in a couple of sections, we have a 0 here at 0. Here I would just use quadratic formula, and I get my imaginary roots. What's going to happen here real fast, guys, is that we're going to get into stuff, which one is it? It's 6, I think. We're going to get into these upper degree functions. And we're going to have to factor this and find all the zeros without grouping, without difference of cubes, without sum of cubes, without GCFs, all that kind of stuff. We have to have a way to find our zeros. We're going to be utilizing synthetic division to do all of that. And it gets really repetitive over and over again because synthetic division opens up a gateway to do anything. This is what we're heading towards. So if you look at this right now, it's a 4th degree polynomial that has 5 terms. I can't group it. We grouped them when we had 3rd degree polynomials with 4 terms. I can't factor it like I would a trinomial with a 4th degree because this has 5 terms. Those had 3. So there had to be some other way to be able to do that. So what was developed was a means of testing for possible zeros. What are your factors of 6?
1, 2, 3, 6.
Okay. Plus or minus, right? What are your factors of 2?
1 plus or minus 1.
So what happens here is you get this test that you get these possible zeros. Your possible zeros wind up being at 1, 2, 3, 6, divided out by these, or 1/2, 2 over 2, 3 over 2, 6 over 2. So this tells you that you have 1, 2, 3, 4, 5, 6, 12 possible values that will give you a 0 for the function. Using synthetic division, if you get a 0 at the end, that meant this number, whichever it is, winds up being a 0. So if 1 was a 0, what's its term? X minus 1. You're factoring stuff out. Synthetic division is so stinking fast to use. And this is what we're building towards. Okay? This is what we're building towards. Not doing this to you tomorrow, but this is what we're building towards, all right? This does not go away. This whole synthetic division idea is so easy to use, and you'll use it over and over again when you get back into pre-calc next year. We're right in the middle of using it right now. We're using it with imaginary numbers as well, because you can synthetically divide with imaginary numbers. It's fun. Of course, Jim Kishi just freaked out. All right? But the other class was asking me this stuff. Well, what do I need to know? That's kind of what you were looking at. What do I need to know? Well, everything in 6.1 to 6.4. I mean, pretty obvious on that. What I have done, it's even on the website. There's a tab on the website underneath the homework stuff, underneath the chapter 6. It says extra problems from the back of the book. If you went through that and you scroll through it all, you'll find out where chapter 6 is. Oh, look at that, chapter 6. We started chapter 6 in what? 6.1. So, it might not be a bad idea to spend some time going over, hey, do I remember how to use my exponent rules? Do I remember how to simplify exponents? Let's see if I can, that's going to be a bad picture here. Let me try this again. So if I had to simplify these two, well, on 18, what do you do first? Distribute the exponent. Does it go to the negative 4? Why not? Good. So it's negative 4, x to the negative 10, y to the 4th. Because when you have power to power, you multiply. Which one of those, or how many of those are unhappy where they are? One of them, just the x to the negative 10. The negative 4 doesn't mind, it's just negative to begin with, it just doesn't have a negative exponent. So negative 10 is unhappy, so the answer would be negative 4 y to the 4th. Okay. Same deal with the one below that. When we did these problems, we always rewrote right away to try to simplify numbers first. Well, 2 over 3, that doesn't really do anything, but 2 over 3. All the rest of it is unhappy. Just rewrite everything right away. Don't simplify right away, you'll screw up. Okay? Then simplify. Play the game of war. Play the game of war. I don't know why you guys aren't writing stuff down. You got all this memorized? I know, just some other people just have nothing in front of them besides a phone. You got all this memorized?
Also, don't have my stuff, so
Just saying, you can always ask people for paper. I got plenty of scratch paper too. So. Same deal when it goes down to the synthetic division. Remember, when you're synthetically dividing, you just have to worry about, do you need a placeholder? Are they in descending order? Things like that. You're using coefficients. So if I'm looking at negative x to the 4th plus 7x minus 12, and I want to use synthetic division with 3. Oh, that's really, I mean, you can probably do that without it, but use your coefficients. Negative 1, 0, 0, 7, negative 12. Why do I have to put the 2 placeholders in? There's 0x to the 3rd, 0x squared. Okay, you guys got to make sure you have placeholders in. When you're synthetically dividing, you drop, multiply, add, multiply, add, multiply, add, multiply, add. You will do a lot of synthetic division. We didn't spend a lot of time with the actual graphing. We did the graphing via tails. So if we're looking at it here, x to the 5th plus 2x cubed plus 3. Just which way are the tails going?
Yeah.
down, up. Negative x to the fifth minus 2. Up, down. 3 minus x cubed. Up, down. Very good. You gotta rewrite them sometimes. Yes, ma'am.
It changes direction when a double of the same. I don't know what
The multiplicity
it is. Yeah.
changes direction if it's got a multiplicity of 2,
So if it has two twos.
and it changes direction of 2.
But what about on the graph you're going like this? So when it changes multiplicity, that hits it and goes back down.
What are your, oh, sorry. I wrote that wrong. Example like this, you got a multiplicity of 4, a multiplicity of 2 at 4. So it repeats at 4. Okay. If you looked at the problem itself, and you FOILed it out, you have the first term that's positive with a fourth degree polynomial. So which one are your tails? Fourth degree polynomial, first term positive. Above. Okay. You're crossing at 0, -3, 4. So it's going down, change the direction, it just touches it once. It does not pass
So it
through.
doesn't go through it, it changes
Change
direction.
the direction.
Okay, that's why I was confused, but it doesn't change direction.
Correct, because there's no more. Multiplicity is 1, it just goes through it once. Okay? And like I said earlier, you'll worry about higher multiplicities later. Sums and differences, biggest thing you're going to screw up there is you're going to forget to distribute a negative. Quite honestly, that's usually what happens. Same thing when you're multiplying stuff out. When you combine your like terms, you're making a stupid mistake when you're adding. Slow your brain down, okay? Am I right? Yeah. When you're multiplying things through, just multiply and combine like terms. Factoring, there's more examples of factoring. This stuff was what? It's on the website. If you have your book, it's page 9 something or another. 947-ish in that neighborhood. They're just problems to look at. You know, people are always like, oh, I don't know what to do, I don't know what to say, I don't know what to do over. Well, we've done everything. You're not getting a smart calculator, I'll tell you that. I haven't decided if I'll let you use the silly calculator, the unsmart calculators. The dumb calculator. Because you really don't need them. Okay?
You want to double check my work? You got it there.
I'll bring you an abacus.
Nice. I got one at home.
I don't have one either.
How's your abacus? How's an abacus gonna help us grab?
Throw it up in the air and see where it lands, right? Tell us which way the tails go. I don't know. Throw it and see where it goes. Guys, I don't know what else to tell you. I mean, we've done all the stuff. When we start up on Thursday, we'll start doing some of those rational zero theorems where we're going to put together what are all of our possibles. We'll start with that. It's relatively simple to start with, and then it just builds out of there of using synthetic division over and over and over and over and over and over again. All right. And plotting it, and then we'll plot them, and then we're going to graph them and continue from there. All right. Other questions about any of that junk? What's that? No, I don't have any of this. I don't think the solutions for the back of the book ones. I don't think I have copies of those, to be honest with you. Let me see.